All right, so today we are talking about the fourth part of the final, and it's higher degree polynomials. So we are just talking about end behavior right now. End behavior is at the end of a graph, like for instance, if you have a graph that looks like this, and it's bouncing there, and it's cutting through there. How did it end? It went down at this end, and it was going up on that end. All right, so the one they're going down like that, that means the equation started with a negative, etc. If it starts with a negative here, that means that it's going down on the right. How do you know if both ends go the same way or if they go different ways? Even or odd, very good. All right, so if we had a problem like, for instance, number 1, is it going up or down on the right? All I care about right now is the right side. Up or down? It's going up because it's positive. How about number 2? On the right-hand side, is it up or down? Ooh, it fooled you. Because see how that's the lead coefficient? It's just not in front. So it's a negative, so therefore it's going down. All right. Which one's this one doing, up or down? It's going down because the lead coefficient is actually that one. All right, and how about the last one? Up, because the lead coefficient is actually this one. All right. Now, how do you tell the other side? Well, you tell based on if it's even or odd. If it's, I've circled all the lead coefficients now, and their degree, if it's even, like the 6 and the 4, then both ends go the same direction. If it's odd, then both ends go opposite directions. You know, like one's up, one's down. All right, so then from there, it's pretty easy to do those. All right. So let's look at a few more things. I don't think we need to practice that. This. What degree is this one? A common mistake is people think it's degree 3. It's really degree what? Degree 4. When they're written this way, you don't pick the biggest one. When they're written this way, you got to think, if I multiplied it all the way out, what would the biggest one be? Okay? This one, if I multiplied it all the way out, what would the biggest degree be? 2. Therefore, it's a degree 2. You could think of it as adding the 1 plus the 1 makes 2, but I like to think of it as if I multiplied it all the way out, what would be the biggest degree? And it would be in this one. 3 plus 3 is 6, plus 1 is 7. All right, good enough. Moving on. If you want factor to general, anytime you want general form, generally, just multiply it out. I don't think we need to practice that. That's really easy. How about this? Do you remember that these are called, there's 4 different things? Roots, solutions, your zeros, x-intercepts, okay. And this one right here is a local maximum. This is not, because that's not a high or a low spot. This one's kind of tricky, but it's actually increasing the whole time through there. And so that one is not a maximum either. It's not actually a low spot. If you think of it this way, water would not collect right there because there's no low spot. All right. This one would be a minimum. This one would be a minimum. All right, next thing is absolute maxes. That's like the highest it ever is. This assumes it's going to go up forever, and so therefore there is no maximum. Is there a lowest spot of them all? Then there is an absolute minimum, and it's right there. Can you be both an absolute minimum and a local minimum at the same time? Yes. Just like you could be locally the strongest kid and worldwide the strongest kid, you could be that same kid at the same time. Locally the strongest, of course, the global strongest kid is going to be locally the strongest kid. You can be both. Okay, the extremes are all of the high spots or low spots, and increasing and decreasing. Let me see if I can clear off some of this writing I did. It's increasing in this little zone right here. Do you get that it's increasing? Because as I read from left to right, it's increasing. Increasing from there to there. It's the x values. So if this spot right there is at 1, 2, 3, 4, 5, negative 5, 2, 3, 4, negative 6, negative 5, comma, negative 6, you use the negative 5, the x of it. So this is increasing from negative 5 to that spot, and what's the x of it? Negative 1. So it's increasing from negative 5 to negative 1. That's an interval over which it is increasing. Are there other spots it's increasing? Yeah. Like from here, forever, from here on. What's that then? From there to infinity. Because from here, forever that way, it's increasing. All right? Okay. Next topic. Rational root theorem. F con over F co. factors of the constant over factors of the coefficient. Ew, spelled that terribly. C-O-E. The factors of the constant over the factors of the coefficient. You use that on a problem like this. Let's say you had x to the fifth plus 3x to the fourth plus x to the third minus 2x's plus 1. I purposely skipped what class of the squareds, yep. So if I was doing synthetic, everybody please test the number 1 with synthetic on this. This is more important than that book. Test synthetic. We'll be done soon. 5. No, wait, it's not a 5. It's a 1. Then a 3. Then a 1. Then, wait a minute. A 0, that's right, because we have to hold the place. There were no x squareds in here. There's 0 x squareds, so I put 0. And then a negative 2, and then a 1. Would you test 1 for me with synthetic and see if it works? This needs paper or your iPad. Either one's fine. Nope, didn't work. How could I have changed this problem so it would have worked? What I had to do is just a simple little thing and it would have worked. One would have worked. Think about it. What makes it, how do you know if it works or not? The very last number ends up being a 0 here. Right? How could I have made it so it would have worked? Yes. Change that blue plus 1 at the end to a negative 3. Do you get how if I make this a negative 3, then that would make this a negative 3, and then when I take negative 3 and 3, it makes 0. Now, I'd like you to write me then, what is the answer? If it worked, what is the point? It goes like this, a parentheses here and a parenthesis around all that stuff. You remember this? If you don't, you need to learn it now because it's on the final. This part right here, I'll help you get started, is x minus 1. Do you remember that this 3 is a constant and this 5 is how many x's we had? What I'm talking about? And this is how many x squareds we have? X cubes and x to the 4th. And put a little plus anytime there's a gap between them. There we go. What did I just do? I factored this big, unholy, awful thing into this times this. At least I now know what one of its roots are. Remember this? The one of its roots is 1. That means that if I graphed it, it would touch at 1. And furthermore, it looks like it's not a double root, and so therefore it's just a cut through. All right, so that's the next thing we're going to talk about is, let's say that you had a picture like this. Do you remember what degree that is based on its bounces and cut throughs and all that stuff? What do you think? Degree 3. All right. 2 for that, 1 for that. Now we're going to do something different with your iPads. I want you to get to a blank page. Be prepared to write a giant number on it using a thicker than normal pen. And I'm going to put a graph up here, and I simply want you to tell me what degree it is. I'll warm you up on this one. This last one, you would have written a giant 3 because this is 2 for this, 1 for that. What total degree is it? And you write a big number on it, and then you hold it up so I can see what your answer is. It'll be like 1, 2, 3, 4, 5, 6, 7. I won't make any bigger than 7. Okay? All right, here we go. What total degree? That's, dang it. It's supposed to be bouncing, but my alignment's off, so it's really hard to make it bounce and not. write the total degree on there. Hold it up. I can see a lot of people have got it. Your iPad looks rather crude, sort of fleshy colored. All right. All right, good. I'm seeing pretty much everybody. Did you leave yours at home or something? Oh, okay. No problem. No problem. All right, next. This is a little tougher one. Tell me. See if anybody remembers this. Don't say it. Write what degree you think that is. A lot of quick answers. That's good. Interesting. One of my best students got it wrong, but everybody else has got it right. Okay. This is a triple root. That was nice. I got it wrong. That's a triple. That's a single. That's a double. What's that add up to? That's a 6. Yes. I won't say it. Okay. Now, last topic. A lot of your homework is like this, and it'll tell you that this was like -3, and this is like +1. And it'll ask you to tell what root it is and tell what it is doing there. Well, how would you answer that? Well, this one is bounce at what? -3. And what would you say about this? Cut through at 1. Okay, so the root is 1, and what's it doing? It's cutting through. Last thing, that's also known as multiplicity. If they ask what is the multiplicity at that spot, you would say 2. It's a number. What is the multiplicity at this spot? 1, because it's only a single root. The weirdest one is the snake. It has a multiplicity of what? 3. All right. Good. I think you've learned everything you need for now. That was day 4 of the packet. You have the rest of the time to work on your packet. You do not want to see any games out during this time. If you have finished your packet, however, that would be a good reward for having finished. Doubting anybody will have that happy circumstance. I want you to work today. You might get more times where I have you fool around, but this is not one of them.